The talk I wanted to give tonight is very much in the context of the studio. We've been doing here on the theme of concrete, lightweight concrete, and this idea of fabrication. So what I wanted to do is show the talk tonight in the context of how we work in the practice and how we think about material and this idea of research and how that interacts with practice and our academic work, where we sort of run these areas as autonomous areas within the practice, but very much with the interest of a kind of mutual informing of these areas with each other. In a way, this has come into, I guess I'd say, a sharper focus in the last 5 or 6 years, where we've set up research as a kind of autonomous practice within the larger practice, and continue to teach. Regina, my partner at the TU, and I'm sort of jumping from university to university in the last few years, but how we tend to approach this kind of work. And so one of the things we started doing, and really very much with students, was this idea of active archiving, which was a process of looking at machines and materials and how we might use them in our practice. So, and this was really about having students look at these things, understand machines, their capacities, how we can use them, how they affect material. Again, under the auspices of a larger argument, which was about how to treat material, and how that might lead to, say, form making, or how that leads to spatialization. So back in again, about 5, 6, 7 years ago, we started to look at machines, laser cutting of sheet metal for Trumpf. Trumpf is a machine tool company based in Stuttgart. As their machines would continue to evolve, we would look at their machines to understand, again, what their limits were, what the economics of these machines were, and how these things could slip from a kind of industrial world to one where this could begin to affect, say, architecture. So what we were doing at this time was master planning for these guys since the late 90s, continue to add building projects here. Here, I'll show it a little bit later, an entrance pavilion back over here. But to really understand at the same time what they were doing here, their technologies and their systems, and how we might begin to actually use that for the construction of their own projects. So we did this in a kind of very linear, fundamental way, where we'd look at their basic technologies, which was 2D laser cutting, was introduced in the 70s, and how that might affect the cutting of, say, sheet metal or other materials, and how we might begin to apply that. So again, we'd look at a particular machine and understand, again, what its capacities were. 2D laser cutting is fairly straightforward, cutting sheet metal on a flat bed. This can be programmed to cut pieces out. In the beginning, we would look at sort of very fundamental kind of screen elements, or pieces what we would talk about having a kind of almost a kind of accessory status in a building, where we'd produce these pieces and then start to embed these kinds of elements into an architectural project. About this time, we started to look at scripting software to produce patterns, simply different kinds of patterns, kinds of shapes. In the meantime, scripting is something we use, I think, in a much more integrated approach, where now it's more about solving problems of geometry, solving problems of construction, again, where there can be an idea of repetition in a project, and at the same time allowing for variation or deviance in that same system as we use in our construction projects. So as an example, we're engaged, like everybody else, in the European competition system. There was a feeling where we wanted to get more out of competition systems, where we would actually start to embed research projects in the competition work. So we'd be invited to do a paid competition, but would try to use that at the same time to try to win a competition, but at the same time to think about it as a kind of research project in its own right. As an example, we looked at the Gewandhaus site here in Dresden. As you remember, Dresden was heavily destroyed in the Second World War. It was this Baroque city on the river here, and there was a site across from the Frauenkirche here to be constructed as a kind of commercial building with galleries, restaurants, and things like that. The approach was to say, well, we'll make this building, in one sense, quite conventional in terms of fitting within the historical context, highly sensitive, with the argument that we would produce something quite familiar, but at the same time, tectonically construct this in a very, very different way than the history of building with, say, sandstone in Dresden for the last, 100 or 200 years. So the approach was to actually look at all the projects that had been proposed on the site for the last 200 years but weren't built, and then, in a sense, composite all of those different versions into one building here that would be basically our scheme, volumetrically, axial, and in terms of its scale and disposition to the other buildings. So that was an approach for the kind of I suppose, iconographic, volumetric situating of this project in Dresden. At the same time, we were looking for a new way to construct it that would understand, say, the sort of intricacies or complexity of Baroque surface making. So we did a very concentrated study of understanding what those surfaces were, how they're made, the geometries may involve that. With the idea of a kind of stacked system, which could be either a stone, a kind of water-cut stone, or a concrete, a kind of poured system that could produce that. So and again, we started to make these kinds of surfaces of a stack where you have both the kind of memory of the Baroque surface making on here, but at the same time constructing a wall for Dresden in a fairly, entirely, different way of how that might work. So these are, there's a kind of parallel work happening. There's the actual work being done in terms of solving the competition, putting that together, and at the same time generating these kinds of studies that are producing ideas for the kind of construction and wall making of the project itself, so that, again, the building would look familiar as a kind of iconographically historical building like this. It could be quite opaque, or it could be quite translucent or transparent in a view like this. At the same time, with the ambition of using the indigenous local material, but in a sense organizing that or arranging that in an entirely new way than historically that would have been undertaken. Another activity or bending, again, this is always about doing something to something. There's always this idea of action or a kind of verb of doing something to a material that will produce certain results or certain effects. So bending is now, like all these other procedures, is also digitally controlled. So the students, in this case from MIT, would look at a kind of limit of a material, understand in one cut you could produce X amount of folds, then begin to use scripting in a sense to produce almost a range, a limited range, but a range of nesting possibilities where these surfaces could fold and then be, in a sense, a kind of accumulating system or a system that adds to itself to produce surface. Again, producing these completely independent from clients or budgets or restrictions as a kind of pure internal research project, but then being able to sort of pull these things out of the drawer and then apply them to a competition like this for the Kunsthaus in Zurich, the competition we did a couple years ago, where in this case the sort of project in the larger project became the idea of space frame making, where we started to think of the folded surface now with a particular scale, and a scale that could be produced in, say, metal or in concrete, similar to the studio work we're doing now. But taking the logic of the fold in the sense of seeing what happens when you scale that up to, say, the scale of a 4-story building here, looking at various different techniques, how to solve that, and then always thinking about that in terms of the economics of the project, how we produce. So this would combine, say, laser cutting, combined with either folding or plates which could be welded or laser welded even together to produce this kind of space frame or array. We looked at other versions where we had a hinge joint where some of these things could actually move or fold or react to different loading requirements or spatial requirements. So again, all this stuff is going on while we're actually producing the architectural competition, which is this volume here. This is that you probably all know, the existing museum over here. The new museum over here with a skin or a wrapper over the top of it being this skin here, which produce a kind of interstitial space or in-between space between the actual gallery spaces and their own particular separate climates and the kind of public entrance space and entry here, and then tunnel connection at the lower level. So that in this case, the space frame evolved into a precast concrete system as a kind of wrapper, and then articulated base where the main entrance is over here. So again, this would be another example of finding an application for this as a research project within the larger museum project here, shown in this kind of slip space. And also in combination with the idea of an energy concept where, again, this is one climate versus the kind of gallery spaces being in a second, and this structural system contributing to that kind of separation and then generating these kinds of spaces within the Kunsthal where you have a very sort of, I guess, introverted space here versus these kind of slip spaces back out to the site and the context of Zurich. And some of the other procedures we do is this kind of fundamental, what happens when you do this to a particular material. In this case, this was a study for a Pavilion with students at Milwaukee in conjunction with the Marcus Prize, where we discovered in Milwaukee steel region that they could produce band steel in a width of about $1.50 meters that we sort of uncoil off of a spindle. This material then could be, in a sense, looped over each other and fastened so that when it's very dense, like here, it's very stiff. It can still make these sort of wide spans. We could drop pieces out like this, these volumetric columns. But to see, and then combine it with a second material, macrolon here, which creates a kind of curtain wall that loops around here. But a very fundamental, and I suppose physical or direct approach of understanding material, again, from the bottom up. And when there's some kind of procedure that you affect it, like it could be like knitting or stitching to produce a model like this, which we could then run by the structural engineers and get a sense of the economics or the efficiencies of a structure like this and how we might use it, how we can contribute it with other materials like a macrolon roof structure that would cover and make the shorter spans across the loops. And spatialize in this way that would produce a particular quality of light, and again the kind of curtain wall idea, making the enclosure here and then giving the project a particular scale. So, and again, some of these projects are sort of in the wings waiting for an actual execution, but it's again a kind of production that often is anticipating a future that we haven't quite got to yet, but that these projects could feed into. This was another project with students in Minnesota where we worked with the Swiss architect Jörg Consett. Jörg's idea was somehow occupying a structural depth. So we constructed this as an idea in concrete where these walls are self-stabilizing. This volume could span from this end to this end quite easily in a depth of, say, 3 or 4 meters. Using the sort of serpentine shaping of the kind of webbing walls here as a way of stabilizing that section, and then attaching it to the top and bottom chords to create a large span structure. So, we'll look at things like this. This is the Jefferson's serpentine walls at the University of Virginia, where you have an extremely thin brick that's incredibly strong through this serpentine action, and then kind of revisit that project against what our ambitions for a much more, in a sense, three-dimensional matrix of the same idea. So these are techniques where it has a spatial or formal identity that's in a way coming out of the logic of its own making or of the logic of its own production. Revolving the laser cutting, I've spent a lot of time in the last few years on this one. I really like it because you've got a three-dimensional object, which is a profile, a tube, which you feed through a cutting head. It goes like this, and it can move like this. And there was all these, we discovered that you could produce, multiple pieces out of one cut. You could produce, repetitive elements, or each one could be a unique shape. And again, these exist sort of, or came apart, or came out at the beginning of the process just to see, how long it would take to cut a piece like this. A piece like that, what the logic, what was the level of detail, what were the structural capacities of these pieces, again, as a kind of testing and then evaluating afterwards. So we discovered we could produce repetitive pieces. We could sort of graft them together in a fairly easier to make them much longer pieces. You could produce a whole kind of array of different sized pieces, again, often where we could cut multiple pieces out of one profile without wasting any material. That was also a kind of interesting idea of sort of harvesting these elements. And then at this time, we're really starting to use exhibitions. This is at the Schweizer Architekturmuseum in Basel over the topic of ornament, where we were asked to make a piece for that. So we used that in a way as an excuse to produce a piece. This piece was kinetic. These pieces could move in the context of some of the other guys, Ido's project here, Jürgen Meyer back here. But not that we decided at one day simply we were going to be architects who make ornament, but it would almost seem a kind of natural outcome of what these machines could do rather than a kind of ambition that, we're going to be. But, rather than this whole argument of ornament and crime, it was really simply something that used to be quite difficult to do in terms of time and manpower, to something that's quite easy to do with these kinds of machines to produce these arrays. So again, the prototype in the museum context is something in between, I would say, the more experimental level of the work to an actual architectural application. So whereas this thing had this idea of movement or kinetic thing, again, in a sense, it was unprogrammed or independent from any particular architectural project. In a later iteration of something like this, it might evolve into something like this. This is a rotating screen wall with shaped profiles for a showroom in Sweden, where the kinetic movement could have to do with visibility of products or a very sort of incremental sun screening of the project. But this would be an example of how you take something at that kind of exhibition scale to something that might plug in or have a major role in one of our building projects. About a year ago, we were asked by Brett Steele, who I think Brett's lecturing here later, to, in a sense, formalize a lot of this research into a project which we ended up calling Atlas of Fabrication, which with Brett became a kind of manual, in a way, a book that we produced where we included a lot of these studies. It's now something that we can continue to add on to. But it was a way to use an exhibition first here to collect a lot of this material. Some of it's scala, some of it's referring to architectural projects we had ongoing. The show ultimately traveled to Berlin, to the 32C gallery, in these Konstantin Gritschik cabinets here, where we, in almost quasi-scientific way, started to arrange pieces, again, independent from the actual building projects that they supported, but as a kind of collection of material that had its own logic on its own right, in a sense independent from the buildings, even though some of these pieces refer to building projects, which I'll show later. This was an interesting way in terms of constructing our own building catalog, and to think of the work as something that you can evolve in a sense. We archive this work then and then can reapply it or reuse it in our own ongoing projects. So as I mentioned earlier, the architectural exhibition is a nice, this kind of halfway house between the experimental work and the actual construction projects. This is a place where the tube shifted materially to plexiglass. We found a fabricator in Munich who could laser cut these. We used scripting here to make one cut, produces two pieces. Each one of those pieces can be located in this kind of matrix, and then through the geometry become tangent. So in a way, this works as a kind of continuous topographical surface. As a prototype, we kept making it better in the context of a commercial gallery. Refine this by adding, say, LED lighting, and continuing to build and improve on a project like this. So now it still has a certain level of abstraction, but it's working as a kind of lighting element in this gallery space that has a certain scale and relationship to how you move through it, how you experience it, as a piece that, again, is somehow starting to have a more precise, programmatic relationship, to the point where we can take a project like this and scaled it up as a proposal for the, I think it's called Touching the Void exhibition, which is going on right now at the Guggenheim in New York, where we produced a larger scale piece for this with a kind of excavated spiral cut through the piece, in a sense mirroring the spiral of Frank Lloyd Wright's museum. In the Venice project, again, these are all these kind of tube projects. There's kind of one after another. But in the Venice project, we were looking at almost like a game board situation where we had a kind of limited installation size, where we started with these kinds of arrays that could be produced by a physical thing, a crafted metal piece that would fit in there. At this time, we were looking at software, in a way, dynamics of diagrams like this that helped us at least imagine how this thing might change over the course of the 4-month Biennale. And this thing goes on and on and on. But which became this array here. So in a way, this is like the status of the project at the first day of the Biennale as a kind of interior landscape. It was interactive in the sense that people could move these things around in the space. They plugged into a kind of pegboard-like CNC cut floor here. So in a way, it began from a very formal, highly organized structure to a kind of chaotic one where these pieces could be spread all over this particular array. So this is people starting to move through this thing, starting to move it apart. This being the stainless steel tubes here, placed within that very simple sort of plywood base that was CNC cut that these pieces could cut into. So interactive in the sense that this thing could, in a sense, fall apart or kind of like a bad hair day, be moved around on this platform after starting with this. So again, a kind of architectural installation, but also thinking about exhibition, I think, which is fairly common now, not about representation in terms of models and drawings, things we might have seen 20 years ago, but actually constructing, in a sense, architectural environments that can be experienced both spatially or, in this case, physically by moving these things around. The architectural pavilion seems to be, bouncing around from schools right now also as another sort of experimental typology. I'm looking at one outside of this building every day coming here, but it also seems to be an interesting place to work. One of the ideas when we were teaching at the AA in the 90s was the idea of a prototype coming out of a control of a technical system, and these are last things were sort of examples about this. This was a student project that produced laser-cut steel elements as a system for retaining walls. That again came sort of reversing the process where this is coming out of understanding the limits of size and how a material can cut to produce a kind of project. One of the projects we were working on last year before the economic crash brought everything to an abrupt halt was a pavilion for the German Duchess Architekturmuseum in Frankfurt. With the tubes, we had discovered this kind of process of, by serpentine cutting of these things, they make a kind of chain that you can have very complex and different radiuses for this. So in a sense, this is kind of the perfect element for a catenary arch system. But in a way, we couldn't do that, but we learned that we could still digitally bend tube stop in very complex ways. So in going into the it wasn't really a competition. We were actually doing a direct contract for this. We worked with students from Penn and at Harvard GSD, where they knew the kind of dimensions of the tubes, and the radius possibilities started to produce these kinds of models. And it's also another thing I think we like to do is sometimes we work in the studio in the academy, like here, but sometimes we'll bring a decent-sized group of students into the practice and run special projects in the practice. And this would be a perfect example of that kind of a project. So these are guys from Penn and GSD working on these models. We use the curator as a kind of client. He chose this version. In terms of flexibility, and it's a permanent, this is not a permanent, it's a temporary, meant to be a temporary pavilion, the kinds of activities that would happen in a 6-month summer-fall cycle. We were going to locate it here. This is Kuma's tea house over here. This is the Ungers renovated museum over here on the river. So our piece was going to fit here. Again, huge, financial disaster. All the banks pull out of the project. Even though they have all the money, they can just print more. But we end up, in a way, in a sense that we have to wait for this to construct it, we ended up building a one-to-one mock-up of a portion of the pavilion inside the space of the museum in conjunction with some of the work that we showed at the AA. This is the pavilion, how it would be sided, Kuma's tea house over here. A primary structure that works like this. Again, each one of these arch pieces can be unique, and then added a secondary system that literally could have this kind of very simple tie connection here. We're also working with Werner Sobeck's offices in Stuttgart. When we work with engineers, where you typically work with them up front right away to develop ideas together, rather than bringing them in later in the process. And with Werner, this would be an example of both the primary structure, and then with Werner, we developed a shingle idea of overlapping shingles that could sandwich photovoltaic, sunscreening for the pavilion in the summer, and had a very unique connection. So here we're using software scripting to limit the shingles to, I think, 12 or 14 types. With those types, we could, take care of, accommodate any of the geometry on the form. And then went to Werner's office and started to look at ways of attaching these polycarbonate sandwich pieces onto the frame. This is the run of the pavilion. So in a way, you use the exhibition to test this as a prototype, which was good because when you test something, I think it's always important that you understand how things fail. So this was sort of like parametric failure. Things were starting to move and adjust. So we were actually able to use this installation to fine-tune or to actually correct the piece. So this is the one-to-one mock-up. These are the pieces which are attached by a kind of Velcro, so you can just sort of stick these things on extremely quickly. Everything's pre-fabricated. And then even within the time we installed, Werner came up with a better, even a more simple detail with this wire where you could attach these to the tubes. And so even in the kind of 5 or 6 days that we were installing this thing, there was a level of corrections or refinements in the piece that would have or will benefit the actual constructed pavilion when we finally get to it. Concrete has been the topic of this semester work, lightweight concrete. It's something that we've been thinking about and working, the last few years. This is a penthouse for an apartment in Berlin, where the precast pieces were very quickly sort of dropped on the roof to create a kind of apartment space here with these sliding doors that open or close it. This is the apartment. This is an exterior space here, an exterior space, and then this kind of open pavilion space here. But even though typically you would think of building a penthouse as being something very light, but the idea of using concrete here was to produce a material that could do all the heating and cooling. So in a way, since it's on the roof and the roof is exposed, concrete made a lot of sense technologically, ecologically, how we would use that. And one of the things, again, as a kind of student project, we were looking at texturing concrete, which, of course, had a kind of aesthetic reading to it, but we were interested in a more precise way how you could generate more surface by ornamentally forming that. You could generate, say, 30 or 40% more surface area, again, for heating or for cooling, using the concrete itself with coils of water running through it to cool or heat the apartment, depending on what time of year it might be, and how that could begin to combine with other materials. So, I mean, one of the things I guess that I still really like about Germany is a kind of willingness to do things, to try things that are non-standard and outside of the catalog. So this is an old East Berlin concrete factory where they would produce these mats for us to form these. They're quite rough in a way, but which is also an aspect that we liked a lot. But the ability to still try things and to see how they work. So these are the positive, then it's a negative, which they make out of rubber, which they can release off through. But we're always a bit surprised that it's possible to produce these kinds of projects and then work with energy consultants. In this case, this is the tubing that's running through the concrete with water, which is either chilled or heated, so that all of these pieces, the ceilings, the walls, everything are these very kind of low, conductive and reflective surfaces of the project itself. Other pieces had to have, in this case, in the pavilion space, spans up to 12 meters. In this case, we combined precast concrete with a steel fin. This is these guys lifting. They closed half the street here, really drove the neighbors crazy, and lifted these things one after another, and then dropped it on the roof. The crane was huge, so we could have done 4 or 5 construction sites at the same time, just go to one roof to the next. But this was, but it was at the same time, it was a very, very quick process. This is this kind of hybrid structure of steel with the concrete, which also has the tubing run through it. And in a sense, historically, the copper roofs is an old, historically an industrial type of roof in Berlin. In a sense, reassign that type of roof again to a kind of modern penthouse residential project, which is this one. And then at the same time, bringing in other areas. This is a screen wall from the Sweden facade, which we brought in here. Still trying to figure out how to get it to move. But again, as these systems accrue, we can pull them out and apply them to these construction projects as we're going along. The smart material houses. I think I showed a few images at the presentation at the beginning of the semester. The smart material houses, a competition in Hamburg in the so-called EBA area. Again, there's a history of doing competitions for housing projects in Germany that goes back a good 50, 60, 100 years. In this case, Smart Materials was again to begin with a material idea. In this case is a lightweight concrete as a kind of structural element, as a kind of multitasking element, really. In this case, we worked with Mike Schleich, who my students also saw in Stuttgart or in Berlin when we were up there on our field trip, but was to produce a new kind of housing type in terms of using material. We could build this for 1.9 million euros for 6 units. We could look at it very specifically in terms of what it would cost, where these pieces could be produced, who could do it, how we would do it. So in a sense, it was a real project, looking for a developer to produce it. We loved these kind of images of Berlin from the 50s with Khrushchev here, standing here, looking at this model at Plattenbau construction, which was this kind of infamous housing technique in Eastern Europe of precast concrete pieces that could be added, this kind of house of cards, in this case on rails, so you could literally build these kind of infinite blocks by just sort of rolling them out. At the same time, they were able to incorporate an amazing amount of variation within these kinds of systems of window systems or ornamental systems on the ends usually. Sometimes the Kunst am Bau or the art, these would be art projects, part of that. So I think there was, even though these types were totally destructive in terms of the European city in a way, we were interested in historically revisiting a project like that, but with new terms and at a completely different scale. The infra-light beton is you use recycling glass. This is it's almost a consistency of lava, a stone. It's a third of the weight of regular concrete. And in a way, that was going to be the building block. We did this, we wanted it to be smart, so we were looking at the CO2 effect. We realized that wood was a -1, and our material compared to regular concretes is much better. So the balance between these two materials was quite attractive. We thought about how we could construct these things by shipping these pieces on site. So within, say, 2 weeks, you could put up the rough framing, the rough structure of these wooden slats with these elements in a very, very quick way. It was also this idea of returning to things like poché, the idea of wall thickness being something that could be beneficial or attractive in lieu of, say, steel and glass, or history of modernism, which was all about thinness and narrowness in this material. Again, because of the kind of insulating values of this is actually an attractive thing, and this kind of fascination with this reversibility of interior space making versus a kind of exterior surface. So, and through some of our other techniques of laser cutting, we could now use this stuff to produce reusable formwork, where we could simply put these pieces together to produce a form, pour this and then open it. And then another level of detail in this would be, again, this idea of surfacing the larger surfaces, again, both ornamentally, as well as this idea of generating more and more surface area. So the actual element is this, again, this multitasking element in the sense that it's a self-stabilizing piece. It's doing the heating and cooling. The finish on the exterior is the same as the finish on the interior. You could flip this piece upside down and it works just as well. We could produce with 2 or 3 types by filling them, pouring them at different heights, and by flipping them, an enormous amount of variation along this kind of perimeter wall. So in a way, the hardest thing about the whole project is simply making the formwork for this. But once that's established, it's fairly easy to repeat more and more of these pieces. And again, since the wood and the concrete is a self-insulated material, we could kind of get away from the kind of German bugaboo of cold bridges, warm bridges, and have a highly plastic, highly articulated, in a sense, spatial exterior facade by sort of terraces out here, and then combining that with a more or less kind of conventional wood window system with an exterior layer on it, which kind of protects acoustically in terms of where this is located in Hamburg, and then at the same time produce rescales in a different way on the interior in terms of producing these kinds of spaces. So in a sense, they can be used in different places. And again, the construction principle is identical to how we did it in the model. You put these chunks of pieces down, they're highly stable, you put another plate on top of it, the next one, almost like a house of, well, like chunky cards, but cards that can stack on top of each other to produce this kind of a structure. And then produce these kinds of interiors where you have an interior that can have an orthogonal core, it can have partition walls, or it can be an open loft system, and produce these kind of spatial effects in relationship to daylighting and these kinds of openings around it. This is a kind of, I guess, down view on the project in terms of these kinds of spaces here and program uses, generating enough flexibility in these floor plans, again, with the idea of getting married with a developer to see this project through in the next few coming months. The research project is only to say the projects I'm showing here are I think 2 or 3 projects that we finished in the last couple of years. And it was an idea, I think, about this technology trickling down into our building projects. So it was this kind of this little soundbite from Icon magazine, but that we weren't going to simply work at a kind of exhibition scale or boutique scale, but how this material could again fold into ongoing construction building projects in the practice. So the TrueTech building, where it's mostly invested, is how the facade works on this, and for a project in Korea where we'd never been, it's probably one of the most self-referential buildings we've ever done. Used to working on projects like the Dresden one, where context and history are really driving the generational ambitions of the project. Here, it was really about a kind of, for us, a kind of generic site master plan, the DMC, which isn't too far away from the DMZ. One of the last building parcels, large building parcels in Seoul, which is this, super heterogeneous city of low scale, medium high density, set within this incredibly dynamic, really dramatic landscape. Of course, like many Asian cities, it's also, visually incredibly, really goes. This kind of psychedelic landscape by night was another aspect of this, an architecture of almost, phenomenal kind of architecture of light and image. So that this, in a way, was the master plan we inherited. We knew we had a building site here. We knew that there was some kind of park here, but nobody could tell us anything about what these buildings were going to be when they were constructed. And it's literally a kind of instant city that gets built from left to right. So with this kind of unknown aspect of it, we became interested in historical models like Harry Cobb, I.M. Pei's Hancock Building in Boston, which was done in the 70s. As you remember, there was this kind of argument about how it would assimilate historical context like this, or atmospheric, like the sky, in a certain way. But one of the things we were fascinated by was a surface trying to be perfectly flat, at the same time generated these incredible sort of variations in the facade. If you remember the history of this thing, the windows are popping out on people all over the sidewalk, and so it was kind of a mess with it. But this idea of a kind of dynamic facade is something we wanted to try to do again in a kind of visual way, knowing that we wouldn't know what the context would be like, what the buildings would be around it. So we started producing these in the kind of ultimate Miesian way of producing these mock-ups in the courtyard of our studios in the background. So these were like 1 to 3 mock-ups, and discovered with a very, very shallow relief, we could create this almost kaleidoscopic facade iteration like this. We would, talk to local critics, artists like Olafur Eliasson, who were working on similar concepts at the same time. But how we could do this, produce a facade that in a sense skins a kind of shell and core building with underground parking here, We moved the core off to the corner, but a kind of lattice or a lace-like structure that could wrap around the building over a steel frame construction. So, a future iteration of that facade would be the actual bearing structure, but in this version, it's independent as a curtain wall. Here you can see, the city literally being built from the right to the left. These are empty sites that are now since been filled in, and these are the neighbors, which are these kind of not too bad, modern office buildings, kind of KPF type level, and then our project, which is situated in between them, which works like this. So we also discovered that unlike American cities, these cities are 24 hours. There's people living in this area. There's activity at daytime, activity in the nighttime, and in a way the facade really does become this kind of liminal surface between a very private interior, offices and showrooms, and an extremely public exterior in terms of activity and people on the street. And we could produce, again, with this facade really with one type here, which we could flip over here, a three-dimensional type and a two-dimensional type. Again, a huge amount of complexity where there was a desire for the building to read as multi-story, but there was also a desire for the building to read as something more abstract or more as a kind of monolith. So these were just these are studies where you go back to drawing and looking at patterns that we could achieve with limits on glass. The frames were made in Korea. The glass came from the States. So we started with a facade grid and then could add a rhythm of diagonals through that, add offsets, three-dimensional pieces, this kind of building up of a facade system with, again, fairly limited basic types that produces eventually, and understanding the economics of a three-dimensional element versus a two-dimensional piece, and also the kind of economics of a facade that we could do in Korea, but would have been for us probably unaffordable if it was in the Friedrichstraße in Berlin. So despite this thing about globalization, I think landing in a place like Seoul, there's interesting restrictions, also interesting possibilities that we don't have in another place. So this is the park connection here, this indentation or entrance over here. The core is offset here, virtually a column-free interior space with large spans across to the core. And then you can see in this section that, again, that facade operates in a very flat dimension of about 30 centimeters deep. We could carry that across to create a kind of roof garden in this tech park or high-tech park, and then with the core and underground parking over here to produce this kind of a wrapping or kind of a skin. The geometry at one point was we weren't getting it, so we would go back, which maybe is a lesson for my students also, that this kind of way of back and forth working where we'll just produce very simple analog models to understand something that we're not getting digitally or three-dimensionally. So I think a lot of the times there'll be a lot of parallel work in our practice in terms of how you understand or figure out different kinds of systems. In this case, again, looking at limits of parts and types, a clear glass, all reflected glass, and a so-called shadow box glass in the more acute geometries, and then looked at ways for fabricating this. One of the things was looking at as off-the-shelf window profiles that we could cut in different ways. The Koreans bought CNC technology from Germany. They taught themselves how to use it. They started producing a test prototype, a mock-up, using all standard off-the-shelf aluminum extrusions from the Korean building market. But finding one where they had enough sort of material that it could be modified in a fairly simple way by cutting it and then combining it with these joint stiffeners, which in a sense control and the tolerances for the geometry and hold that into place. and then had these guys starting, basically taught themselves how to use this technology, and then started to go in to production in their factory in Seoul. And then the way we did this, we brought in, this is Gary from Hong Kong ARUPS. Gary would come over and do workshops to control the quality, to make sure things. So you have these very high-tech going on, and also super low-tech, just sort of kitting the windows. This guy's doing to seal them. But being able to produce, fairly complex elements with a fabricator that had never done anything, anything remotely like this. The client had to be assured, so we did a mock-up, and then sort of blasted it, with rain and wind. It worked. It was no problem. So then we were able to go into production, build these things, prefabricate these, also bring them on site, stage them, and then start to lift them into place. You can get a sense of the scale. Some of these are quite enormous, quite large, and then could quickly fit them into the existing rough construction concrete and steel framing that's around it. So the effect from the interiors is these are these shadow boxes, which is a translucent glass, versus the clear, which create this kind of lattice-like interior. Again, the spaces are fairly loft-like, fairly open, and in relationship to a facade to the exterior that could change fairly remarkably and quite dramatically over, say, a 24-hour time period, from extremely transparent to translucent to one that was affected by local advertising. This is the LG building across the street. It's LED advertising, which in a way the facade could appropriate and even use that as part of the dynamic of this facade, which of course can be activated by weather or by people walking by, cars walking by. The window cleaners are total lunatics. Or again, the kind of LED advertising around it. And again, these are just some different views, aspects of it. Other projects, engineering projects within this project, larger project, these showroom bay doors that open to bring large machinery up into the spaces. The special project was the entrance, this indentation here, where I think there's an interest in both a kind of shallow spatial depth of the facades, but also one that become, in a sense, much deeper. Again, another project which I think is something we think about continuing. We developed with Mike Schleich, our structural engineer, in Berlin, a particular stair that would work like a marionette that could be suspended from the steel structure of the ceiling with a very light steel plate, which is the steel here, which is hanging by a series of very light steel rods, or which also kind of create the handrail for the building, as well as rescaling the exterior facade as an interior facade in another material. This is a large wood in a kind of 2/3 scale reiteration of the facade from the outside. And I guess because this was our project, because it was Korea, within 6 months, our facade had been copied perfectly in downtown Seoul as a boutique, and in some ways even better, which was both, I think, horrifying and flattering at the same time. But it was quite amazing. The Gatehouse project, the two other projects that I'll show tonight was the campus I showed you in the beginning, the Trump campus where we've been working for the last 10 years. This project and this project. Also worked with Sobek on this. The Gatehouse project. The original campus was 60s, 70s. This used to be the front. They acquired this, and this is sort of the way we're used to master planning, is where it's quite unpredictable, or what we call soft master planning, where they acquired a spice factory, they acquired this. So in a way, the back became the front of the building, and there was the addition of this Gatehouse to this landscape campus for clients and employees both to use. So quickly, in this image, the gatehouse does two things. I mean, the first thing it does is it demonstrates quite precisely the technology that's going on. So it's the first chance to use their technology to produce a project like this. And of course, at some point we were thinking of architects like Prouvé, who would use sheet metal comprehensively all the way through the project for the structure, for furniture systems, for cladding systems, window systems. And this was something that was a project that we were quite interested in revisiting. It works as a kind of frame, also spatially to the campus. On the interior, it's a kind of what the Germans would call the kind of Visitenkarte. It's quite muscular with the cantilever. But we discovered that around this time, we discovered they were doing decking for things like ship decking or for tables, laser cutting and welding that produced these very light structures, but very, very, very strong. And the question was, could we assume some of this technology but scale it up into a very dynamic, large 20-meter cantilevering roof? So there's two columns here in tension, and then the roof spanning over here, very flat, with the ability to sort of bounce around on the end of it, and then enclosing that by a kind of curtain wall that continues around it. At the beginning, again, working very early with Werner and his group, we started to inherit these kinds of vector plot drawings from the engineers with the columns here in compression and these in tension. And we were asking if we could make this information visible or legible in the project through our cutting or through our fabrication of the pieces. So in a very naive way, we started by simply trying patterns and go back to the engineers, and they would say, that's a really stupid idea, and that's maybe okay, and that one's stupid too. And then kept going back and forth and literally building the models in the same way, laser cutting these sheets in the way that we're anticipating creating the actual roof at a scale of 1:1. So we finally settled on this version with the triangulation. It was quite stiff, where it would become much more compact at the loading points, and that the extent of the cantilever could be quite filigrane or quite light. So it would vary in this bottom plate, as well as the webbing pieces would also change. And certain areas like the lighting would also complement some of those ideas, the lighting that was happening up in these coffers. To understand that, we would start doing 1 to 3 mock-ups. These are in plywood we did in our studios when we were studying the effects of artificial lighting in these pieces. And then, like the Korea project, we also built a 1-to-1 mock-up to understand the gutter detail, how that could integrate fastening systems, which were all sorts. It was not so easy to simply translate 1-to-1. The ship decking. So we used mechanical systems, welded systems, multiple fastening systems to produce this, also with things like expansion joints.